Man, I hate starting a video like this, but it is what it is. Gentlemen, we're here today, and we're here to talk about Mr. R's Henry. The downside with shipping anything in today's shipping environment. You see it? Whoop. A little dovetail going on here. He sent this up because the amplifier wouldn't key, but we can see how the frame has been pushed over. We got an excess gap over here. So this whole thing's been shifted over and up. I can fix all of this. I got to document it first and see what he wants to do. The way this was packaged was, this was sitting like so in the packaging. This is the chimney for the tube. This is a little Teflon chimney that's hooked up to this metal plate. This is the inner high voltage shield. And the hardware for the high voltage shield and stuff was in this little bag. And the fuse holder, I think I can salvage this. It got dropped and got dropped against here and pushed against this fuse holder and muffed off the fuse holder. So this is our high voltage fuse because it's 3 amp at 1.5 amp. 3 amp or 1.5 amp. That's what it says on the back. This is our power fuses over here. But yeah, we got one of the case screws is missing out over here. That's not a big problem. I can fix that. I can straighten this up. I just got to take the side armor off. This will take a little bit of time for us to get the body work on this squared away. I have no idea what we're going to find on the inside, but at the end of the day, this is what we're doing. So gentlemen, here we go. Let's restore a Henry 3K Desktop Classic. So this amplifier, if you guys had smell-o-vision, you'd be able to tell that this guy's a smoker or cigar smoker. I simply sprayed this side of the cabinet down because it was, well, this putrid brown. And that's what came off. This whole side of the cabinet was just brown, so I don't want to get this all over me. So let's see if we can get this cleaned up a little bit for this guy. That's what came off after I got all this off. So I called and I talked with him, and he was explaining to me that, you know, he likes the cigars. So be it. That's our safety interlock for the high voltage over here. Jesus. This poor little fucker took a beating, man. It's 4 amp. The entire inside of this thing is just coated with love juice. You know what I'm telling you? Yes. Smoking and radio electronics, it just doesn't jive, man. I'm telling you, the whole side of this thing was orange. Like, I don't know if you can see this discolorization here, but that orange. But with this the tiniest little amount of elbow grease. All right, so virginal towel. It's not too bad. That cleaned up okay. See if we can get the, it's like the lettering is yellow and stuff from the stain. And really, this isn't that bad. It's bad when the lens starts to get discolored, though. Then we got to take the meter off and soak it in hydrogen peroxide to I honestly don't care. I understand that part of my job is to clean up. I get that. This is making me chuckle. This is making me chuckle. All right, let's turn it up on its side. Part of what I got, oh, I didn't see that. Part of what I got to do is figure out why this thing isn't keying up no more. Talking on it, stop keying, he says. I'm like, okay. So we'll have to go in through this bottom plate and see what's going on the inside. I might end up having to take the whole body off of this thing because this is dented and this is dented. Depends on what the design's like on the inside. We'll get to that in a minute. Just want to get this all wiped down so I feel comfortable putting my hands all over it and knowing I'm not going to get third-hand tobacco poisoning. Remember, this is coming from somebody that smoked 2 packs of cigarettes a day for 20-something years of his life, so. Ugh. All right, let's move on here. This little phenolic board is the only thing keeping the whole high voltage rectifier brick in place. So this was getting banged around the whole way here. Let's pull this pink tape off of this. Wow. 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 So I got to take this outer shield off. And the face is attached to the outer shield. The knobs and the drive gear are the only thing that's going to support the face. So I think if I take that screw blown out, gone. I think if I pop these screws off and then take the outer perimeter screws off, I can take the outside case off and then I can, man, I'm going to have to be careful. Because there are no replacement parts for the face of this thing anywhere. It's just a self-tapping screw. Okay. Shh, Luke, don't say anything. Just don't say anything. Just fix the amp. Get on with your day. Okay. There's probably some hidden consequences to undoing these screws too, like part of the RF deck's gonna fall out or some shit. Okay. Okay. Yeah. So I can bend that back square. See? we break it down into its individual parts, I can bend that back square and punch this up and rebend this back and bend this back flat and get the bottom squared away. I got to take this apart so I can fix this anyhow. So okay. Okay, so we got the outer armor off. Now I can go and bend that back. Get that squared up. I'll show you why I gotta be so careful here. This whole faceplate is just hanging in free space. It's free balling, right? There's nothing supporting this faceplate. And these little drive couplers, yes, they're out there. This one here, this little plastic coupler, little nylon coupler. If I don't break that, I will be very happy. Because that's a lot of work I don't want to have to try and hunt down. So, shit. I don't see anything obviously broken. But as loose as everything is in here, we could just have a loose wire, and that's the reason it's not keying up. I don't know. I know first things first, I want to repair the capacitor, get this so it's not floating all over the place. I'll take like a Teflon rod and shove it down through and pop the cabinet back out. We'll get this squared up here real quick and we can get moving on, and let's figure out why this thing isn't working here. I just pulled the bleeders off this, so there's no way there's any extra electrostatic charge on this thing. I'm just checking it. I fished this out and rebent the ears that hold the capacitor down so they actually can bite on the edge of the cap and hold it in place. This has been floating around for a long time. This really has. This is a 25 microfarad, 5,000 volt oil filled capacitor. And as soft as this cap is, and the discolorization I see of things here on the lid, and then this. If we look really closely here at these rub marks slash arc burns, arc burn, this thing was plugged in and hot, and this cap has fallen against the breaker. Then there was this Teflon little shim that was threaded on top of the shafts for the cap that was keeping it from hitting the ceiling. I think this has had more problems than it just won't key up. It's kind of obvious. Okay, this cap is sticky. I don't know if it's sticky from the juice oozing out of it or from cigars. Either way, we got to test it before I put it back in the amp and bolt it down. I'd rather stop now than down the road, you know what I mean? So, let's see what our ESR says here. Wow, look at that. 23.82. All right. Oh boy, you got lucky. As wet as it is around the tabs of this cap, man, I don't. Lucky. I'm going to clean this up before I put it back in here. Lucky. So, check the bridge. I'm not seeing the rectifiers. I'm not seeing any shorts. So, we're going to go in here and we're going to... Oh, shit. We're going to add some hardware. We'll get this bolted down. I think somebody halfway took this apart. This guy's from New York, so I can't call him. It's too late at night now. It's 1 o'clock in the morning, New York time. I honestly think that somebody took this apart trying to figure out how to fix it, and then they didn't put it all the way back together before they sent it here. Which is kind of interesting. Damn, it's just hanging out there like it's magic. No, what I did is I put double-sided tape on the bottom of the cap to help hold it down and keep it in place for the trip home. It's this cap has seen way better days. Okay. Let's see if we can get this side to bolt down now. I seen the train a-coming. It's coming round the bend. I ain't seen the sunshine since I don't know when. Okay. Okay. That cap floating around in there loose could have caused so many damn problems. I can't even imagine. He's so lucky that when that thing hit the backside of that breaker, ooh, it didn't blow a hole in the metal, or in the metal, and caused all the magic electric schmoo to come out. All right, so now all I gotta do is lay this thing down, and I'm gonna go finish up the body work for the armor. We got the back end kind of squared up a little bit. Still got a little tiny bit of a down loop here. Straight enough. Okay. Let's get the bleeders and everything put back on here. And yeah, we're gonna get the body armor all banged out straight, and we'll get that put back on, and we'll get new screws and that kind of stuff put in it. Just debating if I should drill these holes out, these holes here. Drill this hole, and the one in the back here, the one back here, and put crush nuts in it so we can use threaded hardware instead of using, you know, machine screws. But I want to get this all put together and make it so that this safety interlock is now working and everything's really truly grounded, but that cap is not coming out of there now. Man, I can't believe that was just floating around. Anyhow, moving on. Because why not? I'm here. I might as well make it so the customer can at least put real hardware to hold the body on, and I don't know, maybe some rubber feet. I know. Novel. I know. Let me go do the other three. Why? What is it with this amp where everything is just so effing messed up, man? Everything's bent. Nothing quite lines up. And there's so much stuff that's been disconnected or loosened or... I don't think I'm the first guy to be inside of this old girl, I guess is what I'm getting at. Let's sneak this puppy down on here. There we go. So now we got a good bite on that. This is the main support bar for the back of the amplifier. And the hardware that holds this in place is completely stripped out. And I mean, hogged out like a crystal meth smoking Tijuana hooker. I mean, hogged out. I mean, it's bad. So my idea is to crush nut it. And I might need to modify some things just a little bit. Oh, come on. There we go. Okay. If I crush nut this in just the right way, and then go in and counter drill. I don't need to counter drill on this corner, this back corner here. Maybe. Cool, don't even have to counter drill on this side. Good, so now we've got a good solid connection on the corners. So now we got some structural rigidity. That's a technical term. Rigidity, not rigidity. Rigidity, man. I got me some rigidity. All right. So, just like everything, the right thread hardware is not available. Because remember, half the hardware on this piece of gun, some over, is stripped out. So we're gonna have to supply our own here. Oh my God, it's got boltable strength now on the corner. What? Say what? No. Okay. Yay. Now. I gotta put this back together a little bit. Then I can bypass some safety interlocks we can turn on. We can take a look at what it's actually doing. And I gotta repair the fuse holder yet. Remember, the main reason it's here is because the amp will not key up. I don't know about bias, I don't know about any of that stuff. All I know is the amp will not key up. Power supplies all look okay. I checked all the glitch fuses for everything, everywhere. All right, let's make this round again. That's what she said. Okay, so we're gonna kill two birds with one stone. I feel very confident that I can go ahead and turn the switch on. I don't have to bring this up on a variac. It's kind of like I spent the last, I don't know how many hours going over this circuit and looking at everything. I feel very good about this. So this is our 100-to-1 reduction probe. So for every 1 volt we see here represents 1,000. This meter all should come up to about 4,000 on the plate. Got our grounding stick. And then the other thing I want to point out is our meter lights. One of the things the customer requested, amp does not key, replace lights or modify lights so that I can see them. That's what checklist I'm going down here. So what I pulled out of there was this LED gobbledygook, whatever. This was just hardwired in there. I have in my possession, and I've been lucky enough to inherit this, I had a gentleman send me a whole box of different lamps. I've covered this in many other vintage pieces of equipment. This little pen adapter tool has been a lifesaver a dozen times, especially when it comes to getting your big giant man sausages down in there. And I have it cupped out just enough to grab the end of the bulb and build it. Okay, it's what they call the tweaker's hose nose right there. I built that tool a long time ago. Anyhow, I changed to a different, slightly different bulb that's a little bit whiter versus the soft light. And then I took and I moved the bulbs because they've got one going this way and one going this way. And if you adjust the bolt, the nut and the bolt, you can, on the back of the light element, they've got a little spade fork system that you can slide the bulb up and down. So I brought the bulb real close to each one of these windows. So it's going to be a little bit sharper white, and it's going to be significantly brighter because of the proximity of the bulb. And I think that's going to solve our problem. But right now, all we're verifying is not looking at RF, not looking at that, we're looking at that, high voltage. And we're making sure nothing blows up. So this should come up to about 4.012, somewhere in there, and this should come up to about 4. So here we go, contact. Easily seeable. And we're about 3,883 volts on the plate. See 4,000 here, 4,000 there. Should have 0 AC ripple now almost. And nothing. Good. Good deal. Bet if we put the tube in this and load this circuit, I bet it sits at about 3,800. Okay. Now we're to the tricky bit. Let me let the high voltage bleed off on this. Then we're going to ground, and we're going to isolate, and we're going to ground, and then we're going to short out. Every time I work on anything with high voltage, I'm going to start showing the high voltage stuff. I know it's boring as hell, but it might actually save somebody's life that watches one of these videos. And literally do not get me started about 2-piece amplifiers and how they're death machines. Don't. We'll be here for 3 hours of you listening to me bitch about how builders are lazy, selfish, dumb, opening themselves up for lawsuits. If you're going to work with anything in this high voltage realm, got to have a shorting bar, you have to have a reduction probe. I hear this all the time, but what about the meter? The meter does the same job as the reduction probe does. No, it does not. No, it does not. This is independent of anything in the amp. What if I turn this on and this meter wasn't working? How would you know when the circuit is depleted? You have to have this probe. You have to have a probe. Have to. I mean, if you don't want to and you're just trying to be the cool kid on the block and willing to risk your life and ride the lightning, hey, slow clap to retardville you go. That is what it is. We're gonna let this bleed down. There's 187, 169, 160 volts left to go. Bleeders are working, caps holding voltage, there's no ripple going through. There's better ways to test for ripple, but we're not gonna bother with it right now. Let me show you the tube. That's cool. Oh, one of the most expensive tubes in radio. A yu-121. This thing's a beast of a tube. I mean a beast. Oh yeah, you smoke cigars, don't you? Remember back in the day? This is Tom Brokaw with Mikhail Bernashkinoff or whatever, and he'd stick the microphone up in Homeboy's face, and they'd have the placard, so you couldn't forget that you were watching MSN or NBC. Oh, that's cool. I am glad that this tube is not as gross as I thought it would be. Usually, these things, when they're in a smoking environment, they're just gross. The heat just globs onto the tobacco, and then the dust sticks on the sticky heat, and it, oh. What's going on there? Well, yeah, we'll come back to this. I was a little afraid the tube would be a gross ball of nothing grossness, but it's not too bad. I'm going to take this opportunity to take a few minutes before we put the tube in there to cook all night long. Here's the stock lamps, by the way. I want to figure out why the thing is not going into transmit mode. I really, really want to know why it's not going into transmit mode. And I think the owner does too. That's probably the reason he set it up here, right? Right. Let's take a minute. Let me look at that. Let me figure that out. And we'll see if this is a quick repair or not a quick repair. So we're going to flip it over. The bottom plate's already off, and we're going to spend our time down in the bottom of this thing. It could be as simple as a relay coil being bad or a wire broke off or whatever. But before I go any further here, boop. Okay. Now the RF deck is grounded. Let's make sure our power supply is pulled. Now we're going to flip the amp over, and hopefully no more parts fall out. So far I've had this fall out. I have no idea where this goes. I looked all over in the linkage in the bottom of this thing. Everything's got a set screw in it. And then this hardware for the tube fell out of it. This well, journaled freaking screw, and that guy fell out. So we'll see. There's other stuff. I can hear other stuff rattling around, but I've had all the cases off, so it's rattling around someplace. We'll see what happens. We're going to flip this over and flip it around and make it so that I can stick my hands in here and find out what the hell. Okay. Let's see here. Let me get around the other side of the camera. Go ahead and flick that on for a minute. Okay, so there's a vacuum relay for the output side, and then the old Henry style relay for the input side. So all I'm making sure is that we got voltage and the key pedal has worked. I've got the step pedal remoted and hooked up. And if I'm not mistaken, this works on a 30 volt system. I'm not mistaken. So let's see here. Yeah, we got voltage. I can clearly hear both relays clacking and moving. So it tells me it's going to be one of a couple of the things. We got a connection from the outside world from, like, let's say over here, the input coax. Pardon me, input coax, output coax. We have a connection somewhere from the input coax to this relay that's gone bad. The relay itself has been burnt on the input side. The other thing is that the tube is not coming out of cutoff, or the other thing that it could possibly be is the tube is bad. The tube bad thing we won't know until tomorrow. I will not know until tomorrow, because we got to leave this thing plugged in all night. That thing is latching up like it's nobody's business. Okay, so it's not the relay key-in circuit, and I had a feeling that it wouldn't be, taking into account we looked at the transformer up here on the top side of the deck, and then all the resistors that could possibly consider to be glitches or anything that could burn up going for this circuit. I haven't seen any problems yet. So, all right, let's power this down, and we'll check filament voltage now. I want to check bias flop, see if we've got bias flop, to see if it's coming out of cutoff and go into operation. And then we'll check conductivity from that coax connector to this relay, and then from the relay over to the tube socket. Well, it's going to be over to a blocking capacitor, but if I can get conductivity that far, then I know that it's, now we've narrowed it down to most likely the tube. But I'm not going to put this tube in here taking into account how expensive it is. And that's a $2,000+ tube now. Taking into account how expensive the tube is, I'm not going to put the tube in here without letting it sit and cook with just filament and air on it for probably 6 to 8 hours, which is overnight. And then I'll put the high voltage on it, and then we can check for zero signal. So filament volts, power down, and conductivity from here to the disc capacitor, which is going to be right through this coil, is where I'm going to grab it. So let's see what we get. So according to the book, this thing needs 6.3 volts. This is an unregulated supply, so it's going to rely on the load of the filament, the bulb, the valve, to put a load on the power supply and pull it down. So it wouldn't surprise me if we see around 7 volts, if not a little bit higher. So let's see what we got. This is filament volts, by the way. Oh yeah, 7.28 or 27. Okay. Now we got to check for conductivity to the socket. Real quick, I want to check this here. Because man, have them pins in there been hot. Holy majeez, these two pins have been hot. Okay, nothing's touching. Yep, we're good. We're good. Okay, let's check for conductivity to the tube now. Because like I said, we're not going to see if we got bias flop until tomorrow when the tube's in. We could probe for volts, but it's not going to do us any good tonight. So down in here, we have this little disc capacitor that you can almost barely see. It's sitting right next to where the probe is hooked up. And one of these white wires is the coax that comes around and goes to the relay. From the relay, it comes off the relay and it goes to the coax connector here on the back. And we got the volt ohm meter hooked up to the coax connector on the back. And we'll know as soon as we step on the pedal, we should have a nice irritating screech. Yep, okay, so that tells us that the RF is making it into the tube. Now, shut this off. Remember, there's still 6.3 volts present on the bottom side of this tube, and unless you know exactly where you're sticking your dick beaters inside of one of these things, don't do it, because you'll end up meeting Jesus, and it will be bad, and I'll feel bad, and you'll be telling St. Peter at the gate. Well, I'm here because I watched a BBI video and I was a dummy and I don't understand. Look, don't stick your hands in here unless you know exactly what everything's doing. There's this particular cabinet is low voltage. That is not the case in most of the situation. There could be 5, 6, 7, 800 to 1200 volts negative below ground, mind you. So we'll pull this out of here. And what I want to see now, what I'm looking for is to see if RF can go in from the coax connector back over to here. And we've got direct pass through. Okay, so what we're going to do now, power up the amp. We're going to verify the relays are moving. Okay. So now we are where we're at, or where we should be, or what could happen is where we have been. God, I'm starting to sound like the other person running for the President of the United States. Making no sense. You pick which party, I don't care. What we're going to do now is we're going to pull the foot pedal off because we're not going to key this. We are going to prepare ourselves to run the tube because this thing's been sitting here for about a long while, and the tube's been sitting here for a long while. We need to let the tube run for a few hours so the getters inside the tube can do getting things. I'm telling you, this is not the rarest thing on earth, but this is still pretty expensive, this tube. So we're going to set it upright. We're going to let it sit. Yeah, we're going to put the rest of the air chamber on here so it's got forced air through the anode, and we're going to let it just cook all night long. Filament, no high volts. And I pray to God it's not the tube. Pray to God it's not the tube. All right. Straighten this all out. This was bent up like a taco a little bit ago. Okay. So we're going to let this cook. Let's throw a couple screws in here. One to bypass the high voltage safety interlock. I couldn't help but take notice that this particular pin design for the tube, for the socket, is not the greatest in the world. It's very easy to put the tube in and not have it grab on the pins for the socket. So just kind of putting that out there. I pray at this point, I pray that the tube is good. Because this amp, thank God they built these things like tanks back in the day. This amp has seen better days. It's lived a happier life. But there was so much stuff disconnected, I don't know. And so much stuff not bolted in, and I don't know. This is when we pray that high voltage interlock doesn't arc. Looks good. Looks real good. I'm just waiting to see if I got any heat coming out of the tube. I'm not seeing anything yet. Whew, man, this stinks. There's something not right. Something's not right. Okay. Let's see if the tube lights are not. That tube should be glowing. Yeah. Damn. That sucks. I've already pulled the tube out, and I verified that the tube is actually in the pins. Absolutely no heat coming off that tube anywhere. Okay. Okay, we'll pull the tube back out of the socket, and I should have done this before. We'll take the voltmeter and see if we got conductivity across the filament leads. That'll tell us if the filament's open or not. We might just be done right here. Well, shouldn't have any conductivity to any of these other pins. So the tube filament isn't open. This pin is very burnt. Look at that. And its corresponding pin inside the deck is pretty muffed up. Grab my flashlight, make sure I'm really getting a good jam on this thing. Jesus. That is so loose. Look at this. Okay. Step down transformer and variac time. Okay, so this is a pretty simple test jig. This is a, until I haven't used this transformer in a long time. So 100 amp continuous duty, 110 volt step down transformer. We're going to use the variac to vary the voltage going into this, which will allow us to slowly creep the voltage up coming out of this thing. We're hooked up to our two filament leads. We got our volt probe here, hooked up to the base of the tube, and we've got our amp clamp. And what we're looking for is at 6.3 volts to be around 25 amps. I have a feeling we're not going to see it. So here we go. Change sockets, here we go. 10 amps, 23. Oh, it's looking good. So I'm going to look for 6.3 volts. We'll trim right to 6.3. Close enough for the girls I go with, and it's pulling well over spec at 28 amps. Almost 30 amps, 28.2 amps. But it's lighting up. Let's see if you guys can see this. Turn the gain way up here. The tube is lighting. That's a good sign. So that tells me there's a problem with the socket. So now we've got heat coming from the tube. Big time. Turn the gain down on the camera. Let me turn the lights back on, because we're not going to be able to have this on for much longer. This tube's going to get rocket ship hot here. Yeah, see, we're already up to 112 degrees, 115 degrees. It was not doing that inside the box. So there's a problem with the filament power supply or the socket. One of the two. Because this thing was ice cold, but when we look at it, so look at how hot this thing is already, right? 123 degrees. We did not cause any harm to the tube. It is, well, outside of its spec, but only by a couple amps. So I bet you there's a problem with the socket. I bet we're not getting a good enough conductivity at the socket, or we've got something going on there. I mean, visually looking at it, I didn't see anything, so yeah. Ooh, that makes me happy. There might be a prayer for this after all. I must have jiggled it just right when I put it back inside the socket, because now it's making connection, and the amount of air moving through the tube would easily knock the 100-degree air out of it. So it's maintaining its temperature around 99, 98. .4. Yeah. I'm looking at this number up here in the top corner. This number is the temperature at the crosshair. This number is the absolute hottest point that the camera could see. We're staying right around 98 degrees. That tube wasn't lit with the amount of air moving through it. It would have cooled itself off by now. So that means the tube is now working. So the problem, I can almost guarantee with this whole amp, is the box, the socket. The socket. The socket. The socket. And it could be sitting there working, and I bet the finger stock gets hot, and he just jiggles his workbench just a little bit, and it doesn't make contact. Yeah, it would have dropped in temp by now. It's just maintaining 98 degrees. Or 85, 86 degrees. Just floating. Look at that. It's really kind of a piss-ass way that they've got the socket cooled, that there's no air directly getting pushed into the socket whatsoever. It's the two fans in the pack just blowing air through and tumbling around and then coming out the exhaust tube on the top. There is no airflow directly through the bottom of the socket well. So, I don't know. I know we're going to let it sit here and run for a few hours, like a good solid, probably a good 5-6 hours solid. Let's see, what time is it now? It's 12:42 at night. So yeah, I'm just going to let this sit here and run overnight. And we'll bleed off the high voltage in the morning. We'll put the anode ring on it, and we'll see if we can get it to load up and make any power. Till tomorrow, guys. Mañana. So it's been about 45 minutes. That socket's not going to get any hotter. And as we can see, we're still maintaining temp at about 100 degrees. So we're clear to let it run all night long, I think. I was concerned that when it got hot, the finger stock, it's got two fingers that kind of grab around the pin. I was afraid that the finger stock would, and then break contact, and this would sit here and idle all night long, but no, I think we're in top shape. I'll see you guys tomorrow. the next day. Let's go in here and do some work. This thing ran for 12 hours, which is more than adequate. I just got busy doing another sheet. All right. Okay. Now we're going to go back in. We're going to hook up the anode strap to the plate choke. And we're going to put high voltage on it. And we're going to see if it goes bang. Like, legit, I don't think we're going to have a problem though. Either there's a... Okay, so what this has come down to now... Well, no, we're not there yet. I can't make that prediction. I'm going to shut up. I have a sneaking suspicion there's still something wrong with the tube. But... we'll see. If we put high voltage to this thing and it comes right back and it starts saying, hello, how are you? I love you. Great. But then we got to question why it failed. Did it somehow magically pop out of the socket? Did the finger stock come off the bottom of the tube? Or is there an internal break in the tube and we just happen to lay the tube down on the side, and when we hit it with a big transformer, we got everything to hook up for a minute? I've seen both sides of this story happen. That's why I'm like, well, let's not get too carried away there, Luke, and let's not be too overly predicting on anything. I'll change the hardware that's holding the band on for the tube here. I estimate that it'll take us about that much. Or maybe a little more. Back this off, come on. Jeez almighty. There we go. Okay. It's a castle in Brooklyn's where I dwell, brass monkey, that funky monkey. We're gonna go a little bit lower down on the anode. All right. Let's get this all tightened up. This is an interesting outcome. Just moving the tube around just enough to put that strap on and put the lid back on. Remember how yesterday we sat here and we watched it idle at about 100 degrees? It's interesting. 89, 88. 89, 87, 88. Interesting. Okay. We've got our foot pedal hooked up. We've got a radio hooked up. The watt meter is on. Either we've got a bias issue, because I don't think the grid meter is working. That's a 1,000 watt in. Yeah, it's set in 1K. So let's see here. Let me grab the radio, which is the D-Rail Striker 955, by the way. Hello, 1, 2. Make sure I got this turned all the way up. I was using it the other day on something else. Hello, audio. Okay. So we're doing about 80 watts. Let's go over here and look at the 5 watt element. And I'll put a little bit more than a watt in it. Say about 1.5 watts. I'm not seeing shit for Shinola. That tube should be screaming hot. I have a feeling we got something seriously wrong with our socket. Yeah, see, tube's dead. Yeah, ice cold. Yeah, okay. Let's figure out why the tube's not lighting, which is just basically, and we gotta wait for the high voltage to bleed off now. We'll flip it up on its side, and we're gonna go open the bottom plate and see if we're making contact with the pins. I want it to be the tube socket so bad, y'all. Really do. I hope it's not the tube. I think I've had tubes like this where the filament breaks. You lay it down in a certain way and light it. It just makes contact and then it sits. I don't know. We'll see. We'll see. So this is not touching the case by any means. This is our filament volts. There's no load on the power supply. There's no load whatsoever, and the tube's not lighting. I put this clip on there to make sure that we're getting good contact. On the lead feeding the filament. Reach in here and grab the other one. We'll put a little bit of extra pressure on it. Not a lot. 7.15, let's see if the tube lights. Yeah, I think that was the last hurrah for this tube. So the finger stock on the bottom is discolored and splayed out a little bit. I'll show you what I mean by splayed out. You can see these two fingers here that grab the base of the tube, these fingers here. This one that's up here in the top corner has been hot. Not this one, the one that you can't see. It's one there's buried right there, and then you got this set of hemostats going down in there. It's been hot, so the feet are kind of not quite making contact, I would say. So that's what the hemostats are there for, is to try and add a little bit more pressure to the bottom of the pin. Well, even with that extra pressure, the tube is not heating up. So it's a tube. I mean, it has to be. We got the voltage present, everything's present, including the bias flop. Well, bummer. Let's go see if I can quickly find, oh boy, a tube here. Yeah, ice cold air. It's blowing 60, 70 degree air out the top. So, yep, tube. Well, I chatted with the customer, and we've got to go find him a tube. So I've got to call in to all the usual suspects to see if we can find him a tube. But we're not going to see that tube anytime in the near future, and I want to get this returned to him. Like, it's got to not be here. So let's take this. You know what? Here, let's just take this off here. Yeah. So, needless to say, we're done. I'm done anyhow. This thing is in the best condition it can be to go back to him, to be able to be used. Just slide that out. That is obviously bad. See, if we look down in here, see if I can get the camera to get down up in here for us all. If we look down in here, and we look at this pin in the socket, we can see how discolored it is, right? And I thought that was part of our problem. But when I went in there with the hemostats and pinched on there, and the tube didn't come back, that's the end of the conversation. So, I mean, I might be able to rattly tap this around and maybe hook it up to a variac and Maybe get it to come back again, but I don't think so. The way you can't trust it. I mean, you physically, we can't physically trust this tube, right? So it's time for it to not be here. Time for it to go home. We don't ever, by the way, you guys, we don't ever transport these with the parasitic resistor and the anode ring flopping around inside the amp. It will just destroy things. So needless to say, tube's going back. I'm going to send the tube and the amp back because the tube has no value to me and I want to provide him with everything he sent up here. This thing needs to go home and I need to move on to other pressing projects. I got some really cool stuff coming up. Finally got a company that I can source my transformer front and back plates from. I got prototypes of those coming. I'm really excited about that. Let's go ahead and we'll go over here and we'll grab some extra hardware for him. So once I get transformer plates, then we can go back to doing new builds, and that is looking pretty neat. I got some really, really cool stuff coming up. A couple really big power supplies, a couple really big boxes. That 32 pill, I'm going to start on it probably before the end of next week that I've been talking about. I'm really excited to get that done. Brand new hardware. Why do we always ship these things with all the plates in them? Because this thing showed up with this plate and this plate outside, and I believe that's what caused most of our damage back here in the corner. We're going to add more padding, obviously. It's to help add more structural rigidity to the situation. I know rigidity is not really a real word, but it is a word. It adds more strength to the cabinet. Now, we don't have enough hardware for the lids. And that's because I put screws in the bezel all the way around the front and all the way down the bottom. And the 4 screws that were holding the lid in, well, actually the 2 that were holding the lid in, ended up in the front faceplate. And we want that to add more strength to the cabinet. So let me dig around. And hopefully I got enough. Yeah, not in that one. Hopefully I got enough hardware to pull this off for this guy. Well, gentlemen, I want to say thanks for hanging in here with me. No, there's not enough in there either. If not, I might just have to take my happy fat ass over to Ace Hardware and get... Oh, here we go. Thanks for hanging in there with me, gents. I appreciate you guys. Sometimes it's 1,000% repair. Other times, I know everything here is tested and right. And it comes down to the tube. It just comes down to the damn tube. Come on, scoot. There we go. That sucks that down nice and tight. Nope. I'm gonna have to make some hardware. I'm gonna let you guys go. I appreciate everybody watching to the end, but this is concluded. These things are built like a frickin' tank, run like a frickin' freight train. It's just that tube. It's a rare, rare girl. Gentlemen, I say thank you. I appreciate every single one of you. Be well. Thank you, McMahon. Thank you, Siglent. Thank you, Bird. Thank you, Coaxial Dynamics. Thank you, Penta. Big shout out to the Patreons as always. As always. And a big thanks to all of you. All right, I'm going to go run some grinders and stuff. We're going to cut these down and make it so that this can make it home safely and in one piece. Gentlemen, I say, I see you. The biggest mud duck in Idaho. Click, click. I don't know what this is. It's a shirt. This was in the amp, by the way, or in the packaging with the amp. Let's see what we got. This is like a sweatshirt. Pete and Gallardo's Bar, Carmen Pizzeria. The show, what does this say? The shore's famous. The shore's famous. This must be some really, really nice pizza joint. I appreciate you sending me out the shirt, my man. Maybe I'll shrink down to a 3X someday. I think it's thick, but that's nice in the winter. Let's take a look at the back. Neptune City, New Jersey. Well, the next time I'm in New Jersey, which will be later this year, homie, I'll go check this out. That's cool. Thanks, brother. Gentlemen, I appreciate you all. I'll see ya. Click, click.